Find the derivative of the function arcsin x. And usually when finding derivatives, it can make my working a bit simpler to say let y equals my function. So let y be equal to arcsin x, because then my derivative is just dy on dx. Now I can't find dy on dx because I don't know how to find the derivative of arcsin, so I need to do something else first. Well, what do I know about arcsin? Well, I know it's the inverse of sine. So if I do sine on both sides of this equation, I'll get sine y is equal to x. So x is equal to sine y. And I can find dx on dy. So the derivative of sine y would be cos y. And there's a formula that tells me that if I want dy on dx, and I have dx on dy, then I need to do this. Dy on dx is 1 over dx on dy, and so that would be 1 on cos y. So I've found the formula for dy on dx just here. But unfortunately, I would usually expect dy on dx to be in terms of x, and this is in terms of y. So what I should do is to convert that cos y to be in terms of x. How can we do that? Well, I know that sine y is in terms of x just here, and I've got a formula that relates cos y to sine y, so I should be able to do it. Let's see. Cos squared y plus sine squared y is equal to 1. And sine y is really x, so that's cos squared y plus x squared is equal to 1. So cos squared y is equal to 1 minus x squared. So cos y is equal to plus or minus the square root of 1 minus x squared. Now, I can't put plus or minus into my formula because that wouldn't be a function. I need to choose whether it is plus or minus, and the way I generally do that is I generally look at the thing that's inside the cos and look at what quadrant that angle is in, and that tells me whether cos is positive or negative. So what quadrant is y in? Well, y is arcsin x. And arcsin always produces angles between minus pi on 2 and pi on 2. So y is in minus pi on 2 up to pi on 2. Let me draw that. Here's my unit circle. And I've got from minus pi on 2 to pi on 2, which would be these two quadrants. Let's see. All sine, tan, cos. So they're all positive here, and cos is positive here. So cos is positive if y is in those two quadrants. So therefore cos y is positive. So cos y is equal to plus 1 minus x squared square rooted, and therefore dy on dx is equal to 1 on cos y, which is 1 minus x squared. And that's the end of the problem.